It's going to go pretty quick. The idea here is that um, I look at reduce. Slash inject is like this class of like builder enumerables, and like in the idea is that they build something and then return it to you. The idea here is that we take an array. I think that the stereotypical or like standard case for using this. No, phone, stop it. Standard use case for reduce inject is when we want to kind of sum things up. So let's do this. Right. Right, and how we can get this at each other is we do this. And this is the kind of standard syntax. Sorry. So what happens when we use reduce is that we have two block parameters here, two block variables here, and essentially collector is this kind of like this stateful kind of collection that we kind of iterate through each time. And the first value, the initial value for collector is whatever gets passed to reduce here. So because this is a 0, collect the first time through is going to be 0. So we have collector, and the second block variable here is just going to be like whichever item we're currently on in the collection. And so when we go through the first time, collector is going to be 0. We're going to add the number to it, which is going to be 1. So that's going to be 1. And the idea is that the value of collector the next time through is going to be the return value of the block. So we have this, like I like to do an explicit return here. Like saying like, hey, this is what's going to get returned over. And if we do this, and if we run this, what's going to happen is that we're going to get, oh, math, 15? 15. Because the first time through, reduce collector is going to be 0, number is going to be 1. So we're going to add that to it. Collector is now going to be 1. So collector, we return 1. We go through. This time, collector is going to be 1. Number is going to be 2. 1 plus 2 equals 3. So that the new value, the return value of the block is 3. Cool. So we flip back around again. Collector is going to be 3 because that's what was that was the return value of the block the last time. And so 3 plus 3 is 6. Return value of this block is now 6. We come back around. Collector is now 6. We add 4 to it. That's 10. The return value of this block is now 10. We come around last time. Collector is now 10. We add 5 to that. Collector is now 15. And collector now is 15. What this entire bit of code will return at the end is what the block returns at the end. So essentially the final condition of the array is what collector is. And this is like, and this is just a quick, like this is just sum. This is like kind of what I consider like the standard use case for reduce backmodel. Like the method sum is a relatively new invention. And like this is literally how we had to sum things up in a variable like beforehand. We had to do it the old-fashioned way in the snow uphill both ways, which is essentially what this is instead of that kind of sum. So I look at this like, hey, we build things, right? In this case, like the idea is that whatever we want to build, we start off here. And in this case, this is a 0. That being said, we can use reduce can duplicate the functionality of every single kind of enumeral there is. The problem with reduce is that I think that people initially, when they learn how to use reduce, they use it for everything, which is like, no, like don't do that. I think that like it falls into this habit of clever code. I think that the worst things to see in a project or any kind of things like is this idea of clever code. When someone sees a thing, is like, oh, that's a good idea, I'm going to do that. Like, no, why would you do that? That's terrible. It's like it's hard to read. I think reduce follows the thing. I think that it falls into the category of like when you have a hammer, all you see in the world are nails. Reduce is very specific use cases. And like we want to use them for the use case. Other than that, we always want to use the purpose-built enumerable, like be it find all, max by, whatever. Like use those. Those have been highly tuned and optimized by the Ruby team, so like they will be used instead of reduce. I like reduce in general because let me put it this way: if I'm using each to do something, and I want to avoid that local variable collector pattern, reduce is what I use. The other side of this is that like if there is no other enumerable to do for me, I'll use reduce to do so. And the thing is that I want to show you that this does not work on just numbers. It works on any kind of collection. So let's do this. And if we want to get these all uppercased, right, we would just do array.each, nope, dot map, right? Like this is how if I want an array with all these names uppercase, this is how I do it using map. If I were to do that with reduce, how I do is array.reduce, and here my thinking is like, okay, so what kind of object do I want this to return? It's going to be an array, right? So I have an array there. Arrays do, I want to do my collector, and I'm going to have each thing as a name. And so what we're going to do is collector dot push dot upcase collector end, and this should do it. Push should return the entire collection. Yes, no, I don't remember off the top of my head. I see a thumbs up there, so like probably. And so in this case, I don't necessarily need that collector, that explicit return at the end. Personally, I have a bad habit of forgetting what returns what, so I will do an explicit return in a reduce just to make sure that I'm doing the right thing. I think it's very easy to like accidentally like forget that and the whole thing blows up and you don't know why it blows up. I think that is especially true for like things where we're building strings. But this is like essentially what we've done here is that we've kind of replicated the use of map, right? Of like we've essentially kind of like done what map does, and like this is more complicated than map, so why would you use this when you can use this instead? So what we've done is we've built, just done that. We can build. Let's build some hashes with it. Let's say we wanted to make a hash where the keys were the first letter names and the things were the contents, the whatchamacallit, the values were an array of the names. We could do array.reduce hash do. Right. And collector is just what I call it because it makes it easy to think in my head, like this is the kind of aggregator of the collector. You can call it whatever you want. We can call it pizza. We can call it whatever, it works. I'm going to do like collector, if collector does that work on a string? I forget. Let's find out. Nope, not dot first. Nope. That's annoying. We can access the name by reference. Yeah, that works. Do that. If that equals 0, we are going to collector name 0 shovelin name, else collector name 0 equals array name. And this is one of those instances where we need to have that explicit return, because anything in this is just going to return the, is not going to return the whole hash, right? So we got to make sure we return the whole thing back. And this is one way we can build hashes. Cool. Other fun things we can do. We can build strings. So reduce do. Oh, hold on. Hi. Okay. I just gave her a treat with her head collar on, and she ate it. So I'm trying to associate the head collar with good times. And cool. Do collector name, and then if we wanted to collect all the first initials for a reason, I don't know. Plus equals name 0. I don't think this one we need the whole thing, but again, this works. And now this will return us an ABE, Abe, essentially. Will? You are muted.
Sorry about that. Yeah, on the hash example you had up, I remember we were talking about it with Megan or Kat or somebody, but there's like a need, you have to return it, the whole value, the whole array at the end of every new hash key or something for it to actually take. Is that sound familiar to you? It seemed like there was something you had to do with a hash.
Not sure exactly what you're referring to. What we did there was just kind of like make sure that we're making sure like we handle default values. Like we didn't set a default value for the array. So I mean for the hash. So we're just making sure that like it will still assign either way.
Okay, thanks.
Mm-hmm. Other question? That's all I got in reduce. There's not much to it. You can do some wild, wacky stuff with it. But like essentially reduce is my tool for reach, where I have to build something where I guess a good kind of idea is that if you need to like, if you have one data type as a collection and you need it to turn it into something else, reduce / inject is probably a good tool for that. As you can see here, like with this example, I converted an array into a string. Before that, I converted an array into a hash. Yeah, because like if you're doing array to array, like map's probably the better tool for that. Yeah, Jake.
So when you did the array to a hash, you're basically just pulling for your key, you're pulling something that already exists in that array. Is there a way to pull in something else?
Yeah. Trying to come up with like anything you have access to. Anything you have access to like is going to be the thing. Like anything that's within the scope that you can use to put in there, you can do that. I can't think of like a well, let's try something different. Let's say let's do this. Right? We could do something like array dot reduce to kind of mirror that example we had before. You know, something like that, right? Like I have access to it, so like I could literally define this as whatever I want it to. You could put it. You could do anything in there as long as it's within scope. This is a bad example. But like that, I think the kind of the message still carries is like you are not limited to what the information you have that you can do with it. You could, I guess we could do something like. Collector count equals name count. Like this, like you can have it like increment, like a 0 is the first thing. I guess that's a use case. Like if like the first key 0 is gonna be the first key. Collector 0 will map to Alice. Collector 1 will map to Bob. Collector 2 will map to Eve. Like that's a thing you could do. But like to be fair, like you just made essentially an array. But like I kind of want to demonstrate like you can have like things like that. Will?
Yeah, sorry. So this actually is the example would work, but I'm not tracking as to why you have to return collector in line 14 again at the end of it.
Yeah, because because like otherwise count, this is just going to return an integer and collector will become integer the next time around. And you can't, integers don't have any keys. Every single time you loop through, whatever collector your aggregator is going to take whatever was the return value of the block beforehand. So if I didn't have this here, so what's going to happen is I'm going to run through the first time. It's going to be, okay, collector is going to be an empty hash because that's what I set here. Collector, so this hash with the key of count, which is going to be 0. I'm going to set that to name. So essentially I'm going to have, like, so essentially what's happening is collector 0 is going to be Alice, right? So we add count, we add one account, count's going to be 1. And now because count is 1, the next time we go through, collector is going to be 1. We lose that hash. We need that explicit return at the end because otherwise you lose persistence. Like that hash, that this collector here goes poof. And so then what's going to happen here is if collector is 1, collector bracket 2, collector bracket 1 is not a thing. There's no bracket method on an integer, right? So you do 1. I haven't done this. What happens when you do that? It's probably going to say no method brackets. Okay, that's weird. I don't know why I did that, but that's not what we were looking for anyway. I have to look into what that exactly does, but that's the idea. The idea is that the collector is this aggregator, is how we maintain persistence. Potentially, one way you could think about reduce is like one way that you might want to think about reduce that'll help you understand is like you think about it as like a recursive function that calls itself over and over again. And like the exit condition for it is like when it runs out things to iterate over. That's like how, and you could do a lot of fun, weird recursive stuff with reduce. I think the coolest thing I've seen someone do is they've replicated flatten with reduce. You wouldn't ever do that, but you could, and he did it, and he did it as like his kind of like mental exercise, so like practice / think about recursion, but possible. Cool. Other questions? That's all I got. There's not much to say about reduce.
So Mike, things like sum or map or whatever we could use in place, we should use, but
yes,
are there very specific instances where reduce would be the best?
I mean, I think that the prime use case for reduce is when you're building something and you're using each to like kind of shovel into a collector. That is like when you're changing data types is probably a good use for that. Like if I wanted to capitalize all those names like I did before, like why not use map, right? You're going from an array to array. I think reduce, and this is just an opinion, but I think reduce really excels when you're trying to go from one data type to another. Like in a number of your independent challenges, y'all try to make the square peg of group by fit in this round hole, right? Because you're converting from like an array to a to a hash, and like I think ideally, my first step, I think that when I'm working this code is that I'll just use each to kind of just get it done, and then I'll probably refactor and reduce. For me, because I'm pretty well practiced reduce would be my first step. But like I think that generally when I'm changing data types is the optimal use case for reduce. Yeah, like, you know, like summing, the items in an array is like a great example of that, because it's like, well, you start with an array, but you really want an integer or float or whatever, right? I also think of it as a kind of like it does literally what it says. We're kind of reducing things down, right? Uh, for the example where I grab the first initials, right? I'm taking this array, but I'm really just kind of compressing it down. I think it's also like inject is also pretty descriptive. It's like what I'm doing is I'm taking this collector value and I'm injecting things to it over and over again until I'm done. Anything else? Nope, that's it. All right, later. See y'all at 1.
Thanks,
Thanks,
Mike.
Mike.